Hi. In this video, we're going to look at vectors that are given in the format of magnitude and direction. We're going to look to convert that into the component form. So we've already covered the reverse direction from component form to magnitude and direction. We're going to look at the reverse of that in this video. So to start with, we're going to have a look at our unit circle and investigating that a little bit, and then we're going to apply it to vectors. So over here, I've got my unit circle. So circle, center at the origin, radius of 1. Now, using our trig functions, we can work out how far in the x direction and a y direction we are at any point. So if I had a line that was coming up here, and I had an angle, let's say the angle was 30 degrees, I can work out what this x direction is and what this y direction is, or what these lengths are, by using sine and cos. So if I enter cos of 30, so cos of the angle, it's going to tell me my x position. If I put in sine 30, it's going to tell me my y position. So unit circles, that's perfectly fine. If I had some negative values, say I had, let's draw it in green, let's say this angle here, I don't know, was 260 degrees. Let's do one that's not an exact value. If I want to know what my y position and my x position are, again, I'm doing the same way. X equals cos 260, y equals sine 260, and it's going to output what my x and y values are. Now, the reason why this is important is because with vectors, we're doing the same thing, but the only difference is we're not doing it in the unit circle. We're doing it with bigger circles, or perhaps smaller circles. So in this case, what I mean is that distance here of, if we imagine this as a vector, that is of magnitude 1. So if we're to calculate how far it is in the x direction, we've got one lot of cos 30. If we're looking at the y direction, we've got one lot of sine 30. If I was to double the length of this vector, if I was to scale it up by a factor of 2, and I wanted to know how far it was in the x direction and the y direction, my x would now be 2 cos 30, and my y would be 2 sine 30. Because if I scale the vector by a factor of 2, I'm scaling the x direction by a factor of 2, and I'm scaling the y direction by a factor of 2. So we're using our knowledge of our trig circle and of our unit circle and our trig functions to apply to our vectors so that we can break them down into x and y components. So let's go through a couple of vector examples. If I was to have this vector, let's do it 1 unit in length. So let's say vector A has a magnitude of 1 and a 20-degree direction from the positive x-axis. If I want to express that vector in component form, I can say that my x direction, or how far my I hat vector, if I'm looking at that, is 1 cos 20, because that's in the x direction. In the y direction, it is 1 sine 20. And because I don't have exact values, I can enter that into my calculator. Cos 20 is going to be 0.9394, and my y direction is going to be 0.34, and that breaks it down into its component form. If my vector wasn't 1 unit in length, let's say it was 10 units in length, then my A vector would now be 10 cos 20 10 sine 20, which would just be 10 times these numbers down here. 9.4 to 1 decimal place and 3.4 to 1 decimal place. And that's how you would convert from your magnitude and direction form into your component form. We'll go through one more example that's not in the first quadrant. So let's draw it up here. Let's do a vector down here and say the angle is 260 degrees and our magnitude is 7.2. So in this case, we want to break it down into its x and y position or its movements. So in the x direction, we are cos 260. And so that's if it was 1 unit in length, the vector, if its magnitude was 1, but its magnitude is 7.2. So we're scaling that vector by 7.2. Same in the y direction. We're scaling that vector by 7.2. And we can get our answers. So 7.2 cos 260. We get negative 1.25. So that's negative 1.25 here. And our y direction, negative 7.09. It's negative 7.09 down. So that's how we convert from magnitude and direction of a vector into its component form. I hope you enjoyed the video, and I'll see you for the next one. This video accompanies a worksheet series that aims to develop conceptual understanding with vectors. If you'd like to access the worksheet, click in the description below.